titration was performed to determine the concentration of some ethanoic acid. They did the following steps. 25 mils of this ethanoic acid solution was pipetted in. So I'm going to put C2H4O2, that's the acid there. And then in step 2, they added some indicator to the flask. A few drops, not being very specific there. Could be a source of random error. It's not a very controlled variable, just a few. 3, a burette was filled. Let's put the burette in up here with NaOH, and it's a standard solution, which is good. Step 4 confirms this because they say that A was titrated with B. Now, whenever you have a sentence that says A is titrated with B, then B is in the burette. Just the grammar structure of step 4. And we've confirmed that in step 3 anyway. Steps 1 to 5 are repeated until 3 concordant titers. All looks good. A systematic error could result if burette tap leaked. No, because the solution would drip down into the conical flask. You would still measure the difference on the burette markings. If the burette readings were recorded to the nearest 0.1 mils, well, no, because actually you can buy burettes with this level of precision. They're called grade B burettes, and they're just slightly less precise than the grade A burettes, which we normally get, which is 0.5 mils of precision. So that would be a decrease in precision, not a systematic error, just using cheaper burettes. Number of drops of indicator was not consistent for each titration. The only issue with that is it would again increase your random errors if you're not controlling for the exact number of drops. It would not be a systematic error, but let's keep going. Hopefully it's D. The actual concentration of the standard NaOH solution was lower. Well, yes, if your concentration of NaOH is actually lower than you think it is, then you're going to need to add a greater volume, and it's going to appear that the concentration of your acid is greater than it really is. It will result in an overestimate. So there we go. The answer is D.